Alright, so here we are with Unit 10, Lesson number 1, and let's just go through the vocabulary. You definitely need to know these two definitions, um, that one. And these are not really vocabulary, they're more of mnemonic devices. They're just things to help you to remember certain facts. You need to know the definition for that, and that, for that, and that. And the other ones you don't really need to know the definition for. Um, This diagram here is something that we're going to learn later on. That's actually an example of a galvanic or a voltaic cell. It looks pretty complicated, and it can be, but we're going to go through it, and I'm sure you're going to understand it when we're done. Here are the objectives. This is what you should be able to do or accomplish by the time this unit is over. So let's actually get into the notes. So let's look at exactly what we mean by excuse me, oxidation reduction. Oxidation reduction reactions are sometimes abbreviated as redox, so it's the same thing, they're used interchangeably. And oxidation reduction reactions involve the transfer of electrons from one atom to another, and both oxidation and reduction occur simultaneously. You cannot have one without the other. And here are the definitions that you need to know. Reduction is when an atom gains electrons. It's going through this again. At some point I'll figure out about that. Reduction is when an atom gains electrons, and when an atom gains electrons, its oxidation number actually goes down. So I'll give you an example. If we start out with copper with no charge, and it absorbs or gains two negatively charged electrons, its charge is now going to be copper with a -2. Now that's not normally going to happen because copper doesn't normally gain electrons, but you get the point here where its oxidation number went from 0 to a -2. That's an example of an oxidation number decreasing. That would mean that that atom underwent reduction. Notice what side of the arrow the electrons are written on also. The next one is oxidation. And oxidation reduction are opposite processes. Oxidation is when an atom loses electrons and its oxidation number goes up. So if we did copper again, but now if it's losing electrons, the electrons would now be on the other side of the arrow. So it would now become a +2 oxidation number, and it lost 2 electrons. Notice what happened to the oxidation number. It went from 0 to +2. So notice in reduction, the oxidation number always goes down, becomes more negative, and the electrons are always going to be on the left side. In oxidation, the oxidation number always increases, and the electrons are always written on the right side because they're being given off. And this is one of those mnemonic devices that we had talked about to help you remember what happens during both. Loss of electrons is oxidation. Gain of electrons is reduction. That's Leo the lion says Gur. And this is just going through a couple of different things that we had just talked about. Their oxidation reduction are simultaneous. One cannot happen with the other. If one atom loses electrons, then another atom is going to gain those electrons. And I'm not going to go through this video just to keep this relatively short. And here's an example. It says aluminum is above copper on table J, so we'll replace it. So if you take a look at this equation, let's just quickly run through what's going to happen here. The aluminum will take the place of the chlorine, the copper. So you'll get aluminum chloride, and you'll end up with just copper. So it's a single replacement reaction. If we want to balance it, we'd have to put looks like a 3 here, a 2 here, a 3, and a 2. Yep. It says aluminum is above copper, so we'll replace. Notice how Al is all by itself on the left arrow with a 0 charge, and on the right it takes a charge. So aluminum is by itself, so any element that's by itself is 0. So both of these are going to be 0. Now if we go back here, and this is not anything new, we've already done this before. Copper is a +2 because since chlorine has 2 of them, chlorine's a -1. And again, aluminum is a +3, and again, chlorine's a -1. So if you look at what happened, the aluminum on the left side is a 0, but it went up to a +3. That means it underwent oxidation. The copper started out as a +2, and it went down to a 0 oxidation number, so that is reduction. And that's kind of the basis of what you're going to be doing in this unit. So being able to do this is important. Taking an equation like we just did, figuring out what the oxidation numbers are for each element, even if they're an element by itself, they're going to be 0. So this does take into account stuff that we've done in previous units. So the oxidation numbers and making sure that they add up to 0 is not something new. You should be able to do this. And that's the end of lesson 1.